All right, here is a short video guide for lesson 8.1.1. Sorry I can't be here to do this one in person, so I'm trying to just make up for what I want to give you guys something to do here. And so I don't want to just throw you to the wind though with this lesson. I want to kind of help you along with it. So here's a short video guide. I promise to keep it somewhere between 10 and 15 minutes here, just helping you along with some of these problems. And our goal here is to start realizing what we're going to be seeing in chapter 8, which is some more transformations to our periodic functions like sine, cosine, tangent. And we'll just investigate some of those trigonomic functions throughout this chapter and see what they model and see what they look like graphically. In class, we really have 8.1 to 8.5. I will probably get 8.1 to maybe 8.4 in the video, and I'll leave 8.5 to you guys. Hopefully by that time, through the lesson, you can see what we're doing here. And then homework, I kept it kind of short as well. That's 8.8 to 8.11. Starting with the first one, the first problem kind of breaks down exactly what we're seeing and what we are going to see throughout this entire lesson. And what it says is Laurel and Hardy are trying to write the equations of a sine function that has a graph with the period of 2 pi over 3 and a horizontal shift of pi over 2 units to the right. Laurel thinks that the equation is written as such, and Hardy thinks it is written differently. And trying to figure out just who is correct here. Remember, when we have this kind of b value, thinking about what this equation is even right here, this b value is what controls how long the period is. And so when they say that the graph with a period of 2 pi over 3, we have to think about the b value there. When we think about shifting it pi over 2 units to the right, that's taking place of this h value here. And so that's when I start evaluating who is right. Is it Laurel or is it Hardy? And to answer that question there, the answer is that Laurel is actually correct. So Laurel's equation is correct. Okay. It says, what's the difference between the two equations? Well, the difference between those two equations is that in Hardy's right here, we're actually only shifting over pi over 6 units. And that would be because if we factored out the 3 so that it was written, and we'll see this in the next problem as well, but when we factor out the 3 and we write it like Laurel's is written, you'll see that it does not have that shift. And so that's really the big difference there, is how much would actually be getting shifted over. They both actually do have a period of 2 pi over 3 because the b value here is 3. But we'll investigate this more in the next problem. We're just going to say that Laurel's is correct. Sorry for the bad handwriting. I'm using my finger on my touchscreen computer. Anything else I wanted to say about this before I move on? Oh, yes. If you want to get a better look at this, I recommend going to Desmos and typing in both equations and just looking at how they differ, because I believe Desmos will give us a good picture of that. All right, let's go on to 8-2 and investigate this just a little bit further. And so to understand why these equations create different graphs and how these actually do have different horizontal shifts, we're going to break it down with A, B, and C here. And it says we're going to examine Laurel's equation, which was the sine and the 3 is on the outside, and then it's x minus pi over 2. And it says for what x values does that actually equal 0? What is the horizontal shift of the graph? Note that it is asking for when the input for sine is 0. Part of the note is a little confusing, but really what this is all that's saying is that if we solve this thing for x and we figure out what x makes it 0, that's going to make sine equal to 0, which is going to help us figure out how we're getting shifted over, because that's like where our intercept would be. So usually our intercept for sine is at 0. This is helping us see what we're shifting it over to be. So if I solve this thing, and this is part A, and it's 3x minus pi over 2 equals 0. Well, the 3 would get divided over and really just go away. So I have x minus pi over 2 equals 0, and that's when x equals just pi over 2, which tells me that I'm being shifted over to the right to pi over 2. In the next one, for part B, we're going to consider his function, Hardy's function, and see why this is not the correct shift and what the actual horizontal shift would be. Remember, in the first one, I said it was going to be pi over 6, and let's see why that is. If I do this, part B, and I look at the equation 3x minus pi over 2 equals 0, and I go on to solve it, that is 3x equals pi over 2. Multiply both sides by 1/3, because that will get rid of the 3. And what I get is x equaling pi over 6, which means I am shifting over to the right pi over 6 units, not pi over 2, which is again why Laurel's was actually the correct equation there. It says in Laurel's equation, the horizontal shift is easily visible. Modify Hardy's equation so that it's more visible or it's easier to see, and that's not too bad for us to do. And it goes back to what I said in the first problem, kind of spoiled it there. But his equation is 3x minus pi over 2. And if we just factor out the 3 and we bring the 3 on the outside, so that's x, well then this would be minus pi over 6. Think about factoring that back in. If you're having a problem seeing that, if you factor that back in, that becomes 3x and then becomes pi over 2 there. We'll go on to the next one. We have the graph of sine. We want to stretch it vertically by a factor of 2. Keep in mind this equation here in the beginning. A is a vertical stretch. B is that change of the period, or when they talked about having the period be 2 pi over 3, that's going to be that B value. The minus h or plus h is shifting left or right, and the k is shifting up or down, and we're going to keep that in mind here as we look through 8-3. We want it to be stretched vertically by a scale factor of 2, so that is like our A value there. Let's label it. That's like our A value stretching vertically. Completing 3 cycles in the interval of 2 pi, well, that's like my B value, completing 3 cycles in that amount of time. Maybe you remember that when we did this back in chapter, I believe, 3. And then shifted up 4 units and shifted to the right pi units. We want to write that equation. So I'd recommend pausing this video, seeing if you can put the pieces together of what we've done so far and actually creating that equation. And then when you have an equation written, unpause it and see if it matches what mine is here. My equation is going to end up being y equals, and again, keeping in mind these different pieces here, and I really should also include in here, I know I'm kind of stalling, I know, but shifting up, that's like a k value, and that's like a positive k value, so that's like plus k. Shifting to the right, that's like minus h. So let's put this all together. So this is y equals, sorry for a bad y, that's 2 sine. And then because I want 3 complete cycles, that's 3. Sorry, terrible handwriting, I know. That is 3. X minus pi, because it's shifting to the right pi units. And again, the 3 is on the outside. That was back to Laurel and Hardy's problem. And then plus 4 on the outside as a positive k value. And then that would be an equation that has the vertical shift of 2, or vertical stretch of 2, excuse me. A horizontal, or 3 periods in the matter of 2 pi, shifted to the right pi units, and shifted up 4 units there. Okay. One last one that I'll do, and then I'm going to leave 8-5 for you, and then if you are done early today, I'm going to just ask that you do some review preview in class, and I said it in the announcement in Google Classroom. I should be hopefully back tomorrow, Wednesday, and if not, I'll create video guides for the rest of the week too. But let's worry about that if it happens. Hope to be back tomorrow, Wednesday. Looking at this graph here, we want to state the amplitude, the horizontal shift, the vertical shift, and the period of this function. And that's a pretty tough one to do. I can see that the function completes 1 full cycle. So we start here at negative pi over 2, and we finish 1 complete cycle here at pi over 2. And so the complete function is happening in really a pi distance there. And we're going to have to keep that in mind when we want to ultimately write my equation, that that's happening in the pi distance. I also notice that the function itself has been shifted down 3 units. Usually we would start at the x-axis, and now we're down 3 units from that. It looks like we have been shifted, either way you want to think of it, we've been shifted to the left or shifted to the right, pi over 2 units. And it looks like I have an amplitude of 2. And so that would be something also that we keep in mind here. So amplitude is 2, horizontal shift of pi over 2, vertical shift, it's pi over 2, sorry. Vertical shift of -3, we shifted down 3 units. And then we have a period of just pi, and we want to account for that. Okay, the whole function takes place in just pi. Which means what that means when a function has a period of pi, that means it'll go through 2 complete cycles. And that's that b value, keep in mind. It'll go through 2 complete cycles, b value, 2 complete cycles in the matter of 2 pi. And so that tells me my b value is actually going to be 2 in this problem. And that's going to help me. But let's write this equation, and then I just want to wrap the video up, keeping it nice and short. Maybe I'll say a couple things about 8-5, but let's wrap it up here. So what we have is y equals, the amplitude is 2, that's like my a value, so that's 2 sine of, and then I have this period of pi, which means, like I said, 2 complete cycles will happen in 2 pi. And since 2 complete cycles happen in 2 pi, that means that that b value is 2. Same kind of thing as what they were saying here. They said 3 complete cycles would happen in 2 pi, so that's why this number was 3. 2 complete cycles are going to happen, so that's why that one's 2. And then that's 2x minus pi over 2. It could be plus pi over 2, quite honestly, but we'll go minus just because I see this dot. I covered it up, but that dot kind of makes me think that they want that to be the starting spot, which would be actually shifting over to the right instead of to the left, but it really does not matter. And then finally, on the way outside of the function, we want a -3, saying that we shifted that down 3 units. All right. 8-6, you don't have to worry about that one unless you want to just kind of challenge yourself. It's a spring problem. We've kind of skipped over some of the spring problems before in class. But 8-5 is just a good one to practice. I should have graph paper still in the classroom where it usually would be on the side table. If you want to take a piece of graph paper for everybody in the group and just work on graphing some of these more difficult sine and cosine curves. Cosine actually is a little different, but not much. And maybe you remember that or what it looks like. And if you don't, unit circle, Desmos, things like that. Use your resources here to complete 8-5. Just remember that the homework is 8-8 to 8-11. I know this isn't ideal way of learning. We saw that last year, but we're going to try our best to do it. If you have any questions, just let me know. I'm more than happy to answer emails or hopefully be back tomorrow, Wednesday, and can try to answer some of your questions maybe then too. All right, have a good rest of your day, and hopefully the video guide was somewhat helpful for you.